Dear students, welcome to my channel Elite Maths class. Today here I am with the second part of matrices. In my previous video of matrix, I have discussed what is a matrix, how a matrix is defined, and what is the difference between a matrix and a determinant, and some types of matrices. Now let us see some properties of matrix and some operation on a matrix. Before that, it was discussed in my previous video how a matrix is represented. This is the very short form or the general form or the general structure to represent a matrix of order m by n. What is order? It is already defined and discussed in my previous video, whose link is given in the description box. If you are watching first time, you first go through the link given in the description box. So this is the general structure. This is the notation how to represent a matrix. This is the order of a matrix. Here the first one, this indicates number of row, and the second one indicates number of columns. So in this matrix there are m rows and n columns, and this one is the shortest form to represent a matrix of order m by n. Here also every element is represented by a suffix ij. The first suffix indicates the row, number of row, and the second suffix indicate number of columns of that particular element. For example, say here a2 3, the first suffix 2 indicates this element lies in the second row, and the second suffix 3 indicates that this element lies in the third row. So this is how a matrix of order m by n represented, or any order can be represented by this one. Say for example a matrix of order 2 by 3, it will be in short form represented like this: aij 2 3. That is, there are 2 rows and second columns. In total, how many elements? Total elements equal to m into n, that is 2 into 3 equal to 6. That is, in this matrix there will be 6 elements and 2 rows, 3 columns. Okay, and the basic definitions are also defined in the previous video. Now start from this. What is a comparable matrices? When two matrices are said to be comparable, and what is equal matrices? Comparable matrices means two matrices capital A and B are said to be comparable if comparable matrices, let A, B be two matrices of same order. Clear? Two matrices of same order, that is A and B are two different matrices but they are of same order. For example, let us take A is a matrix of order m by n and B is a matrix of order m by n. See here, both the matrices are of same order. First one, the matrix A is of order m by n, second matrix is of order m by n. That is, the number of rows in A is equal to number of rows in B, and the number of columns in A equal to number of columns in B. In this case, two matrices A and B are said to be comparable. Then A and B are called comparable matrices. That is, two matrices are said to be comparable if they are of same order. That is, in the two matrices the number of rows must be same and the number of columns must be same, whatever, that is irrespective of their elements. Clear? So in two matrices, whatever the elements are there, but if the orders of the two matrices are same, then the two matrices are said to be comparable. And the second one is equal matrices. These are related. Now for two matrices to be equal, the orders of the matrices must be same. Now let us see the same thing. Say two matrices are there, A and B. A is a matrix of order m by n and B is also a matrix of order m by n. Now say the condition is like that, such that two matrices A and B, different matrices, such that Aij equal to Bij. That is, as the two matrices A and B are of same order, there are same number of rows, same number of columns, same number of elements. Now the fact is that if the two matrices be such that corresponding elements are also equal, that is the to Aij equal to Bij. That means if A23 equal to B23, if A11 equal to B11, etc. If that means if the corresponding elements are also equal, then the two matrices are said to be equal, and we write such that Aij equal to Bij. In this case, A and B are said to be equal, and we write A equal to B. A and B are called equal matrices. A and B are called equal matrices. Let us see a very simple example. Let A equal to 2, 3, 4, 0, minus 3, 5. What is the order of this matrix? See here, number of rows 2 by column 3. So it is a matrix of order 2 by 3. Now let us take another matrix B such that 2, 3, 4, 0, minus 3, 5. It is also a matrix of order 2 by 3. Now what happens? These two matrices are of same order, that means these two matrices are comparable matrices. Now to be equal matrices, the corresponding elements must be equal. This is the condition Aij equal to Bij. It means that the corresponding elements must be equal. Now see here, this one is A11, here it is A11, both the values are same. Similarly see, all the corresponding elements are equal, so here A equal to B, that is these two matrices are equal. Here A equal to B, that is the two matrices are equal. So these are two things, comparable matrices and equal matrices. To be comparable matrices, two matrices must be are of same order. And what is equal matrices? Two matrices must be of same order and their corresponding elements must be equal, then the two matrices are said to be equal. In the next part, let us see some operations on matrices. There are some more types of matrices. Before that, we need to know some operations on a matrices, because some more types of matrices are defined depending on some operations. For example, transpose, multiplication, addition, subtraction, these are some operations. Scalar multiplication, these are some operation on a matrix. So before starting, so what next we are operations on a operation on matrices. Operation on matrices. The first one, let us see what is addition of matrices. Addition of matrices. The condition, let us first take, let A comma B be two matrices of same order. A and B be two matrices of same order. This is the condition to apply addition of two matrices, or to find addition of two matrices. Before finding the addition of two matrices, first thing we have to check whether two matrices are of same order or not. If they are of same order, then only we can find the addition of two matrices. Now what is the process to finding the addition, or how can we find the addition of two matrices? First see the definition. Let capital A is a matrix of order m by n. B is a matrix. What the condition, necessary condition? They must be of same order. B is a matrix of same order, that is of m by n. Then how addition of two matrices is defined? A plus B. Then the addition of two matrices is defined as A plus B equal to, these will be, how to find the addition or plus of two matrices? If the two matrices are of same order, to find the addition, what we have to do? We will have to find out the addition or sum of the corresponding elements of the two matrices. As they are of same order, there are same number of elements in both the matrices, so we have to find, we just have to add the corresponding matrices. So what will be A plus B? This is the general definition. Aij, that is Aijth element of the first matrix, plus Bij of the second matrix, that is Ijth element of the second matrix, and the resultant matrix will be of same order. This is the in general definition. Now let us see an example. For example, let us take A equal to 2, 3, minus 5, 7. What is the order of this matrix? It is a matrix of order 2 by 2. Then let us take another matrix B. Say it is minus 3, minus 2, 7. Say it is minus 9. What is the order of the matrix? It is 2 by 2. Now see, this condition is satisfied. Both the matrices are of same order, 2 by 2, 2 by 2. So these two matrices are of same order, and hence we can find the addition of these two matrices. Now by this definition, what is the definition? We just have to find the sum of the corresponding elements. Therefore, what will be A plus B? A plus B will be n. Again a 2 by 2 matrix, it will be of same order, corresponding elements. See, the first two element, it is 2, here it is minus 3, 2 plus minus 3, so it will be minus 1, that is addition of the corresponding elements. What will be the second element? It is 3 plus minus 2, that is 3 minus 2, 1, here it is minus 5, here it is 7, that is minus 5 plus 7, it will be 2, 7 plus minus 9, that is will be minus 2. So this is the resultant matrix. This is again of same order as of A and B. And what is the process to finding the addition? Simply add the corresponding elements of the two matrices. So addition is clear, the simple one. The first thing, their orders must be same, and the second thing, the process of finding the addition is just simply add the corresponding elements. Now let us see some properties of matrix addition. Some properties of matrix addition. The first property is A plus B equal to B plus A, subject to the condition that A and B are of same order, that is A and B two matrices are computable for addition. Then A plus B equal to B plus A, that is first if you write A then write B, then find the addition, or if you write B first then A then find the addition, both the values are same. This property is called commutative property. This is called commutative property. The second property is A plus B plus C equal to A plus B plus C. This property is called associative property. Then these two properties of addition. Another thing, in my previous video I have defined what is a zero matrix. Now zero matrix may be of different orders. Say A is a matrix of any order, then what will be the addition if we add the zero matrix to a given matrix, subject to the condition this zero matrix, this is not the simple zero, it is a zero matrix. Say A is of order m by n, then this zero matrix must be of order m by n. It is simply as our in simple arithmetic, if we add 0 to any number then we get the same number again. Here also if we add a zero matrix to any matrix we will get the matrix again, it is also equal to 0 plus A. This one is nothing but the commutative property, that is if you add 0 to A or A to 0 the value will be same. These are the simple properties of matrix addition. Now let us see what is subtraction. Subtraction is nothing but addition, the same thing. Before that let us see what is negative of a matrix. Negative of a matrix and inverse, additive inverse. Inverse actually two types. Matrix inverse are of two types. One is multiplicative inverse and another one is additive inverse. So what is negative of a matrix? Negative of a matrix and additive inverse. Additive inverse of a matrix. What is negative of a matrix and additive inverse? First, let A be any given matrix. This is the general form of order m by n. Then minus A denoted by minus of A is a m by n. It is called negative matrix of the matrix A, that is of the given matrix. What is the order of the matrix? It is m by n. Then what is minus of A? Minus of A means every element is replaced by its negative element, or you may say that the every element of the matrix A is multiplied by a negative sign, then the matrix obtained is called negative of the matrix A. Now what is additive inverse? This matrix. Now see, from our additive property, A plus minus A, these two matrices are added. So what will be the resultant value? Now see, this whatever be the order, these corresponding elements will be added. Now see, here it is Aij, here it is minus Aij. That is, if the first element is A11 equal to, say it is 2, and A11 in the second matrix it is a minus A11, so this value will be minus 2. Now what is addition? Addition means we have to add the corresponding elements. So what will be the value of 2 plus minus 2? It will be 0. In the similar way, every element will be 0. If this happens, and this is a trivial truth case, that is every time it will be 0, A plus minus of A, it will be 0 matrix, and then minus of A is called additive inverse. It is called additive inverse of the matrix A. This is called the additive inverse. In the next part we will see another type of inverse which is called the multiplicative inverse. Now see subtraction. What is subtraction of two matrices, or how to find the subtraction of two matrices? Subtraction is simple one, as we already know the addition. So subtraction is very simple one. The first condition is two matrices must be of same order. Subtraction of two matrices. Subtraction of matrices. Let us see the in general form. Let Aij is a matrix of order m by n, and B is another matrix of order m by n. Then what will be A minus B? That is subtraction of these two matrices. It will be Aij minus Bij into m by n. That is nothing but simply first see whether two matrices are of same order. If the two matrices are of same order, then we can find the subtraction. That is, two matrices are computable for subtraction. Then how to find the subtraction? Then we just have to subtract the corresponding elements of the two matrices. For example, let A equal to 3, 4, minus 2, 0, 1, 2, 3, 5, 7. Let us take another matrix, say B. It is 1, 1, 1, 2, 3, 4, 3, minus 5, 0. Then what will be A minus B? As they are of same order, it is a matrix of 3 by 3. It is a matrix of order 3 by 3. So we can find the subtraction of the two matrices as they are of same order. Now what will be A minus B? That is, simply subtract the corresponding elements. Here it is 2, here it is 1. 3 minus 1, 3 minus 1, 2. Here it is 4, 1. So what will be the value? 3. Minus 2, minus 1. The third element will be minus 3. Now in the second row, see the first element, it is 0. Here it is 2. 0 minus 2. So the value will be minus 2. 1, 3. Minus 2. 2 minus 4. It will be minus 2. 3. The same element here. 3 minus 3. 0. Now see it is 5 minus 5. So it will be 10. 7 minus 0. So the result will be 7. This is another matrix of order 3 by 3. So the subtraction of two matrices is clear. So these are two operations on matrices, subtraction and addition of two matrices. For both the cases, for both the operation, the first condition is that the two matrices must be of same order. And for addition, how to find the addition? Simply add the corresponding elements of the two matrices. And how to find the subtraction? Simply subtract the corresponding elements. Then some properties of additions are there. First one is commutative. Here you remember that commutative matrix subtraction is not commutative. Subtraction is not commutative, that is a minus b not equal to b minus a. Subtraction is not associative also. So the properties satisfied by matrix addition is not satisfied by or followed by the subtraction of two matrices. Subtraction, simply subtract the corresponding elements. So these two operations, and the first thing where what is equal matrices and what is two comparable matrices. Hope these two operations and this class is clear to you, all the things are clear. In my next video I will discuss some more operations and some more different types of matrices. So hope this thing, today's class is very clear to you. Thank you for watching.